Hello everyone, welcome to Spark Study. In this video, we'll study about another concept, another tools or technique to find out the stability of the systems. That is called the root locus technique. So it is actually the locus or the path of the poles whenever you change the value of gain or the close or the open loop gain. Okay, what I told you before, the technique which is used for finding the right hand side of the poles or closed loop poles which is located at the right hand side of the S plane, that is called Routh criteria. And in Routh criteria we also study about that Routh criteria is valid only for the system is closed loop system. How could we justify the root locus technique? You remember one thing, except the root criteria, any other technique always follow the open loop systems. Okay, but it actually used to find the stability of the closed loop system. Fine, but the way of solving is for open loop systems. We'll study how to do this one by one. Okay, so the roots of the characteristic equation which are the poles of the closed loop transfer function. Okay, I told you that a equation, the root of the equation always gives the poles in case of control systems, and it determines the absolute stability or the relative stability of the linear seesaw, that is single input single output systems. We studied about the absolute stability, we studied about the relative stability. You, if you don't know, go to the previous videos. Also, the transient properties of the system depend upon the zeros of the closed loop transfer function. This is very important point. The transient property of the systems or the transient response depend upon the zeros of the closed loop transfer function. So the dynamic performance of the system depend on the poles and zeros of the closed loop transfer function. Understood? So Routh criteria gives some a little bit idea about the stability, whether how many poles are the right hand side of the S plane and how many poles are the left hand side of the S plane. To determine the relative stability, especially in system having higher order characteristic equation, the technique actually is very tedious. Okay, fine. I told you I have tried to solve some problem in RS criteria up to fifth order, sixth order. When you go for like thousands of order, then the number of calculation or pages are used to solve the problem, especially actually it is very tedious to solve the problem. This is another technique that is called root locus technique. This is used in case of your Routh criteria give you the tedious working, then you go for this technique. So the root locus is defined as the locus of closed loop poles obtained by varying system gain, which is k, from 0 to infinite. Here it is saying that the roots of closed loop poles. Remember, whatever we are going to study, it gives the idea of closed loop system, but the technique which we follow to solve, we use their open loop poles or open loop control system or open loop system. Okay, we are solving for a closed loop system, but the process we are using open loop system or open loop transfer function. But in case of our RH criteria, we use closed loop transfer function. Okay, so it have some criteria or some condition. We need to follow those two condition. First is angle and second one is the magnitude. Okay, so when you go for S plane, we have a real axis and we also have imaginary axis. Let's say you are drawing a line which is exactly 45 degree to the real axis. Okay, so when the angle is when the line creates some angle except 0 and 90 degree, it actually we need to think about the angle condition and also the magnitude condition. We study one by one. What are they? So the angle condition is used to check whether the poles or the point is located on the root locus or not, and also the validity of locus shape. So let's say I'm giving you a point that is S is equal to 5 plus J2 or minus 5 plus J2. So we ask you whether this pole or this point lies over the root locus or not. You need to check it out. So this angle criteria or the angle condition actually makes you allow to check whether the point or the poles are located over the root locus or not. Root locus is simple connection line of the poles. Okay, we'll see in further lectures. Consider a characteristic equation. What is characteristic equation? I told you characteristic equation is 1 plus g of s into h of s equal to 0. So which is written here, and so if you go further you can see g of s into h of s equal to minus 1, and if you take the magnitude it becomes g of s into h of s is equal to 1, which is nothing but the magnitude condition. Clear? Similarly, what is the angle condition? Angle always gives the angle of g of s into h of s equal to plus minus 180 degree. Students, remember to go further, you should have sound knowledge about the complex algebra. Assuming you know this complex concept, I am continuing. If you do not know, before further proceeding, just get some idea about the complex systems or complex algebra. So how to find the magnitude, how to find the angle, so those things. Kindly refer some mathematics books or any source. So g of s h of s angle equal to plus minus 180 degree. Dear students, a plus minus 180 degree or even the odd multiples of plus minus 180 degree. So let's say 180 or 3 into 180 or 5 into 180 or 7 into 180, all the odd numbers. So how do we generally write to find out those things? Plus minus 2q plus 1 whole into 180 degree. So when you take q equal to 0, it becomes 180. When you take q equal to 1, it becomes 2 plus 1, that is 3 into 180. When you take q equal to 2, then 2 to the 4 plus 1, that is 5 into 180, and so on. Here the q is only the, this condition is called angle condition, and q is the from 0 to infinite. Okay, so these two are the angle condition and also the magnitude condition. So first of all, for further proceeding to any problem, we need to first check whether the point is actually located over the root locus or not. See, unless you, let's say you are a vegetarian, unless I do not know whether you are eating non-veg or not, then why should I prepare non-veg for you? Okay, so before cooking for you, I should know whether you are veg or non-veg. First thing, if you veg, then I will decide what to cook, and if you non-veg, then I will decide what to cook. Fine. Similarly, to find whether the system will exist or not, or the mathematics we need to do or not, first we have to check whether the poles or the point is actually located over the root locus or not. If it is located in the root locus, then we will proceed further. To find whether the point is located on the root locus or not, we use angle condition, and then we go for the magnitude condition to further do all the works. So here I repeat, the magnitude condition is to make you sure that whether the point is located or the root locus or not. And magnitude condition actually give you idea about the gains, what the value of gain, that is k. So angle condition may be stated as for a point to lie on the root locus, the angle evaluated at that point must be an odd multiple of plus minus 180 degree, which is given here. And we can also say that a locus of all the poles or all the points in the complex plane satisfying the angle condition alone is the root locus. Okay, so once the root locus is drawn, then the magnitude condition, which is nothing but magnitude of g of s into h of s equal to 1, is used to find the value of system gain, which is nothing but k at any point on the root locus. It can also be used for finding the roots of the characteristic equation, okay, corresponding to the given value of the gain. Okay, so if the gain is given, you can find the characteristic equation and vice versa. Clear? So without wasting time, let's see the however the angle condition and magnitude condition are not independent. So one implies the another thing, so both are interrelated. So the value of s, okay, that is the point or the poles, the value of s that fulfill both these conditions are the roots of characteristic equation or the closed loop poles. So if s is given some alpha plus j beta and it actually satisfy magnitude condition, also it is satisfy angle condition, then you can confirm that s is the family, s is the closed loop poles in that equation. Clear? So let's try to solve one problem. You can see here, if g of s, h of s is given that k by s into s plus 4, and it asks to test whether s equal to minus 2 plus j5 lies on the root locus or not. Okay, so the system is given, the open loop transfer function g of s into h of s is given, which is nothing but k by s into s plus 4. Here the poles, open loop poles, are s equal to 0 and s equal to minus 4. And it is asking, you see, if s is equal to minus 2 plus j5. So from this equation, you can see minus 2 plus j5 is not the poles. But I told you it's a root locus. That means it's the locus of poles, numbers of poles. What is a what is a circle? It is a locus of point equidistance from the center. Similarly, what is the root locus? It's the locus of the path traced by the poles when k value changes. So it is asking you need to test whether s equal to minus 2 plus j5 is actually located over the locus of g of s into h of s equal to k by s into s plus 4 or not. So once you find out if it is located or not, then you can find out from what value of k this is actually satisfying. So first step is need to find out, I told you na, so whether going further we need to test whether this thing is available or not. That means we think about the angle condition. What is the angle condition says? So angle condition says that, so g of s into h of s angle at s equal to given value, that is minus 2 plus j5, should be odd multiple of minus 180 degree or plus 180 degree. See, so g of s and h of s given that k by s into s plus 4. So replacing s by minus 2 plus j5, we can write like this: k by minus 2 plus j5 into, so s plus 4, that is if you write s equal to minus 2 plus j5, you reach with 2 plus j5. Okay, so this is the angle condition. How to find the angle, you know, in complex form. So this will becomes, the top will becomes 0 minus 180 degree plus tan inverse 5 by 2 minus tan inverse 5 by 2. Why? What for this? This is for a plus j beta. You know that how to find the angle of a plus j beta. It is tan inverse minus beta by a. Okay, so you go through this complex formulation, then you understand this thing. So after solving this thing, you can find out this value becomes minus 180 degree, which actually satisfies the angle condition. What angle condition says? The angle of that transfer function with the same poles should be the odd multiple of plus minus 180 degree. Clear? So after that, once we confirm that it is actually over, I mean s equal to minus 2 plus j5 actually located over the root locus, then we will proceed to find the value of k, and we know that to find the value of k we need to use the magnitude condition. Okay, so angle condition is satisfied, hence the point, that is minus 2 plus j5, is lying on the root locus. Now using magnitude condition, what magnitude condition says? The magnitude of g of s into h of s equal to 1. Yes, so what you do, write the equation and replace the value of s, then find the magnitude. So k by s into s plus 2, that is minus 2 plus j5 into 2 plus j5 magnitude equal to 1. So how to find the magnitude? A plus jb, magnitude of a plus jb equal to a square plus b square under root. Similarly, you find the value, and after finding the value, you see that the value, and when you do cross multiplication, you find the value of k. So here k becomes 29. So it is clear that from the transfer function, if k becomes 29, then the point which is minus 2 plus j5 actually passes through the root locus or lies over the root locus. Clear? So this is all about the lecture. You have got some little bit idea about root locus, and in the next lecture we study about how to construct the root locus and what are the outcomes from the root locus technique. So better you study some complex algebra and try to solve this problem, so that the point x equal to minus 1 plus j root 3 on the root locus for g of s into h of s equal to k divided by s plus 1 into s plus 2 into s plus 4, where k is greater than 0, and obviously you need to find out the value of k at that point. So this is similarly as our previous problem what we solved. Try to solve in your own. Okay, so thank you very much.